It is definitely not A. Why is it not A? Because there's no equal sign. If it's just a less than sign, then you would just see a dashed line. People remember that? Dashed line if there's no equals. If there's an equal sign, then it's solid. It cannot be B because this would say that the slope is positive, whereas we know that the slope is negative. So it's not that either. So the question is, this is negative x plus 1, this is negative x plus 1. Is this a y greater than or a y less than? And what's interesting about this is if you don't know, you can always take in a point, plug in a point. So, for example, the point 2, 2 satisfies the inequality. So watch as I plug 2 and 2 in here. Is 2 less than or equal to negative 2 plus 1? Is that statement true? No, it's not, is it? So this point 2, 2 is not part of that solution set. Let's try this one. Is 2 greater than or equal to negative 2 plus 1? Yeah, it is. And so you can see right now that this point is part of the solution set, so it works for letter D. Works for letter D. Okay? So we're not going to do the other one, but we want to be able to determine if an ordered pair is a solution to the following system of inequalities. So we want to know all points for y that are less than or equal to negative 3x plus 1, and all points for y that are less than 2x plus 2. And we will later graph these and shade these accordingly, but in this situation, we're just going to check. And you can do so by plugging in these values. So I plug in negative 3 for y, less than or equal to negative 3 times negative 1 plus 1. And I get negative 3 less than or equal to 3 plus 1. Is that true? Yeah. Negative 3. Because negative 3 times, times negative 1 is a positive 3. Yep. So that works. So it works for the first one. It has to work for both of them in order for it to be true. Then I try negative 3 less than 2 times negative 1 plus 2. Is negative 3 less than negative 2 plus 2? Yes, it is. So this is a solution to the system of inequalities. The next one we try is 5 less than 2 times negative 1 minus 1. Is 5 less than negative 2 minus 1? Everybody agree that is not true? If it fails for 1, it fails the whole thing. This is not a solution to the system. Go ahead, check the last one on your own. Try the last one on your own. I got yes for the last one. How about you? Good. Flip it over. You should be able to check to see whether or not something is a system, and then you should be able to graph the following inequalities. Okay? So we'll just review how to graph these inequalities. This one is nice and easy. I have a y-intercept of 1, so I plot 1. What is my slope? Negative 1. So I go down 1 and over 1. I have 2 points. Will this be a solid line or a dashed line? It will be a solid line because there's an equal sign. It says y is greater than. So if y is greater than, will I shade above or below? I will shade above. And that is the solution to the system. The next one, notice that there is no slope there. Okay, there's no x. It is a horizontal line. Remember that y equals is a horizontal line, and x equals is a vertical line. So I'm going to mark 3 on the y-axis. Is it going to be a solid line or a dashed line? Dashed line. Y is less than 3. Will I shade above or below? I will shade below. I'm going to show you a different way of dealing with problem number 3 in hopes that some of you may actually make use of this, and then I'll do it the way I think you would do it for problem number 4. But for problem number 3, it says 4x plus 3y is less than 12. I am going to not put it into slope-intercept form. I'm going to graph it using intercepts. If I put 0 in for y, what do you see as the x-intercept? 3. So I mark 3 on the x-axis. To find the y-intercept, I plug 0 in for x. If I plug 0 in for x, what is the y-intercept? 4. Solid line or dashed line? Dashed line. Now, if it's not y on this side, then you got to do something different than just shading above or below. You got to test a point. And a point that I like to test is 0, 0. I'm going to test this point. Okay? Is 0 plus 0 less than 12? Yeah. So I'm going to include 0, 0 in my shading. So does that mean I shade on the left or the right? A shade on the left, and that will include the 0, 0. If it didn't work, then I'd shade on the right. That's the way I would approach that problem. However, a lot of people don't like graphing with intercepts, and they always want to turn everything to slope-intercept form. That's okay. We'll do that with this one right here. I will subtract the x from both sides. I get a negative 3y is less than or equal to negative x minus 9. When I divide by the negative 3, does anybody remember what I have to do? I do have to flip the sign to be a greater than or equal to positive 1/3 x plus 3. Now it's in slope-intercept form. We can carry on just like we would have any other graph. I will go up 3. The slope is 1/3, so I will run 1 and rise 1 and run 3. Solid or dashed? Solid line. And it does say y is greater than, so I shade above. Some of you may wonder, like, why would I show you that example if you could always go back to that? And the reason why is because I don't know the teacher you're going to get next year. But if I was a college teacher, I would not do that way. I would start doing this way when I saw x and y on the both sides. So I want you to be able to adjust if you see something down the road. Okay, so what's different about 5 and 6 is that we have 2 of them. So these are systems then. So we are going to shade the overlapping region. So we graph both lines on the same set of axes. I'm going to mark off my axes as 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. This should be sufficient. And I'll graph the first one in red. So I'll plot positive 3. And my slope is negative 2. So down 2 and over 1, down 2 and over 1. Looks like I have a solid line. Here's where I try to be careful with my graph and my shading. Notice how it says y is greater than, so I'm going to shade above, but I'm just going to draw arrows on that side to remind myself that I shade on that side. Now you guys have a pencil, so you could shade really light if you want to. I don't have the ability to shade really light. Like mine, I can't change that at all. And then this one I'll do in green. I have 1/2 x minus 2. So I'm going to plot negative 2. I rise 1 and run 2. Rise 1 and run 2. Because there's an equal sign, that is also, that was really bad. Oh, it's a little bit better, not good enough. That's better. There we go. There's my line. It says that y is less than, so I'm going to shade below it. So notice how this whole area is kind of divided up into 4 regions at this point. 1, 2, 3, and 4. Can somebody tell me which is the region that I shade all together? It is 4 because that's where both regions are coming together. There you have it. So that would be your final shading. So you could shade light and shade light. Look at the overlap and shade dark there if you want. I don't think we really need to do the last one. I think that you understand what's going on. If you could take out your worksheets and let me make sure that I like the problems that we're doing here. I like problems 1, 2, and 3. I don't like 4, 5, and 6. So how about we cross off 4, 5, and 6? Can we do that? Yeah. The shaded region doesn't work out very well at all. Does problem number 7 have 2 x's in it? Is it 2x minus 4x? Have I not changed that? Oh, there it says y. How about this? Let's do problem 8 and 11 on the back. So instead of doing 12 problems, let's just do 5. Oh, it does? Then let's do problems 1, 2, and 3, 7, 8, and 9. Skip 4, 5, and 6, okay? Looks like the answer key is a little bit off. I made a mistake in the previous time when I put this one together. My apologies. But no need to do more problems than necessary, right? Very good.